Bismillahirrahmanirrahim. In this video, we'll be discussing example 17.7, which relates to application of Fourier series. So this is the question. Find the response IOT. So this is IOT that we have to find. And the input voltage here is a Fourier series. And so what we need to do is to find I is, first of all, we need to find this I, and to find this I, we need to have the complete impedance. Voltage divided by impedance will be the I, and from this I then we can, by current division rule, find I0t. So this is what we'll do. But first of all, we have to convert the circuit into phasor domain. Now, if you look at the input has two components. One is the DC element, this is DC element constant, and this we call is the AC element. This has signals of various frequency, where N is the frequency which varies from 1 to infinity. So we need to convert, first of all, the AC part into phasor. This will remain same whether we go to time domain or frequency domain. So VDC is 1, and this is VAC part. Now, to solve this circuit, we have to write it in somewhat this form, that is phasor form, or we can say polar form as well, that is the magnitude and phase angle. And from trigonometric series, Fourier series, we are looking at this and try to compare with this. This can also be actually written as a more concise form, that is this one, but we are not interested much in this. What we are interested is to find this magnitude. So from here also we can write the magnitude and phase angle, which is in the polar form. Now, what is AN? If you recall from this 17.3 onward, if you read, AN is the under root of magnitude of the cosine term and magnitude of the sine term. So this one, and similarly the phase angle, tangent inverse magnitude of the sine term and magnitude of the cosine term. So we need to find AN and BN from the circuit. Let's see, this is signal. Okay, so to match with this, we have to just break it open or multiply by the outside value. So this is what we have, our signal. And now we can easily compare. This part is our AN, and this whole is BN. Now remember, we have also included negative sign, minus sign, because here it is positive sign, therefore BN will include negative sign. And also there is an N here, so this N will also be part of the BN. So applying this formula, AN square plus BN square under root, this is our AN and this is our BN, taking a square. And simplifying, I'll not explain this, but you can just follow easily, I hope, step by step. This, then this, then this, and this is our final answer. So this value we'll be using as the value of AN. Capital AN we have found, and now we need to find the phase angle. So this formula, again, we'll be using the values of AN and BN that we have found from here. And so the final answer will be minus tan inverse minus N. Now this can be written as plus tan inverse and plus N. And if you have any doubt, you can just use your calculator take any value of n, maybe 30 degree, put this value, find the answer. Similarly, put this value and find the answer. They should be same. Okay, so now in terms of magnitude and angle, our VAC will be this magnitude and this angle. Or we can also write in terms of the this cosine nt plus the phase angle. Just like here, an cosine n omega t plus phase angle. So these are the two forms that we can write and will be using. Okay, now from here we'll get one more information. This is the representation of Fourier series, and if we compare these 2 points, n omega is equal to n from here. And so we can say that our frequency, which we call omega n, is actually n omega naught, which is equal to n radians from here. So we have to remember this point. Now we'll convert the circuit into phasor domain. So there is only one element, the inductance element, which will change. So this will be j omega, and the inductor value 2, j omega L. Voltage will become V phasor. Current will become I phasor. I0t will become I0 phasor. So to find, as we have discussed, to find I, we have to find this impedance, total impedance. So first of all, let's find the total impedance. That is 4, and parallel of these solving, we get Z, and then I will be V over Z. So we are not writing right now. We'll carry it as it is. Value of Z, so it will be like this. Now, to find I0, we'll be using CDR, and I hope you know what is CDR. The current deviation rule, which says that the current in any branch is equal to the total current divided by total impedance. Now, we'll not include this because this current is up to here is I. So, total current divided by 4 plus j omega multiplied by opposite arm. Since we are finding current here, so this is our opposite arm, 4. So, we multiply by 4. And now we'll plug in the value of I that we got from here. Solving, we get shown here. Now we need to further simplify this. First of all, we put omega n is equal to n. So I0 will be V over 4 plus Jn4. Taking common 4. Now this is in complex form, so we can write it in polar form. Let's see. If we recall, the complex form can be written as r theta, where r is under root of this and theta is tangent of y over x. So using that formula from here, we get 1 plus n square and angle tangent inverse n. We're just using this formula. Now for DC component, omega n is 0, therefore n is 0. If we're taking this formula for I0, n is 0 for DC. Therefore, IDC will be, here we'll put n is equal to 0, and the value will be V over 4, because this tangent of 0 is 1. The tangent of the angle has been multiplied by 0, so this will be 0. So it will be V over 4. And since we had already, in the question, this was the question, DC is given in time domain, therefore in the phasor domain also DC will be 1. Therefore, for V we put 1, so it will be 1 over 4 ampere as the IODC. Now let's find IOAC. This is IOAC, the magnitude and the phase angle. And this is VOAC. We'll use that in this formula. IO we have found up to this point, and then we'll plug in VAC here. So it will be VAC over 4 into this value. And we're just moving VAC to one side, so we can plug in the value of VAC. Now this is VAC we had calculated, so we'll plug in that value. And simplifying, if we just multiply all these terms, this and this will get cancelled. So this will be our answer, IOAC. So the total AC current, the total current IO is IODC plus IOAC. Plugging in both the values. And now we can go to the time domain. For DC will remain same. This one, we're just going now opposite of this. So like if we have AN and phi n, or let's say VM and phi, then in the time domain it will be VM cosine omega t plus phi. Now in our case, this signal does not have any angle phi. Therefore, cosine omega plus, no need of writing phi, it will be 0. So this is the answer. A is for the ampere. So this, I hope you have been able to follow this. Please let me know through your feedback. Thank you.